Good morning, everyone. I'm Spot On Weather Meteorologist Matthew Euler. Welcome to my latest video. Now, this is going to be part two of my 2025-26 winter season considerations. The objective of this part two of the series here is to discuss winter seasonal forecast considerations for the upcoming 2025-26 winter season. And in today's part two, we're really going to do a deep dive analysis into ENSO, QBO, the PDO, the PNA, the MJO, the AO, the NAO, the SPV. Whenever you see SPV, stands for stratospheric polar vortex, and then the SST, sea surface temperature anomalies. So we're going to take a deep dive analysis into all these teleconnections. And again, I'm going to basically delve at the end of this video into why I feel very strongly about a certain winter analog going into this upcoming winter season. If we look at the past winters, we look at past winters which featured a weak La Nina to start, transitioning to ENSO neutral. All right, we come down basically, and when I talk about, we look at weak La Nina, we're looking at the Nino 3.4 region water temperature anomalies, okay, in the eastern and central tropical Pacific. All right, so these are the winters that really come up that basically went from a weak La Nina transition to ENSO neutral conditions. 1971-72 winter season started with a water temperature anomaly in Nino 3.4 at minus 0.9, and it eventually warmed to minus 0.4 C throughout the course of the winter. 1983-84 winter season, the water temperature anomalies range from minus 0.9 degrees Celsius to minus 0.4 degrees Celsius in the Nino 3.4 region. The 2001 winter season, we went from minus 0.7 C to minus 0.5 degrees C or Celsius. And this, I'm telling you, based on the forecast, based on what this range was back in the 2001 winter season, as well as the forecast for the upcoming winter season for these water temperature anomalies in Nino 3.4 region, this analog 2001 still remains most favorable match. Now, the 2016-17 winter season featured a weak La Nina, minus 0.6 degrees Celsius, water temperature anomaly, but it warmed to minus 0.2 degrees Celsius throughout the winter. And then the 2022-23 winter season ranged from a minus 0.8 degrees Celsius, it warmed up to a minus 0.4 degrees Celsius. If we look at the latest El Nino Southern Oscillation forecast from IRI, the Columbia Climate School, over here on the left, again, I mentioned this the other day in my video, the blue tall vertical bars indicate La Nina. The gray vertical bars represent ENSO neutral. And you see on this vertical axis over here on the far left, the probability percentages range from 0 up to 100%. So initially in the early part of winter, December, January, and February, we're looking at a greater probability of a La Nina vice ENSO neutral. But when we get to January, we're seeing a higher probability with the gray bar here of an ENSO neutral over La Nina. So we see that transition from a weak La Nina in the beginning of winter right to an ENSO neutral transition as we get into January of 2026. Over here on the right-hand side, I just wanted to reiterate, these are the model predictions, the dynamical and statistical models, kind of showing you where they're ranging. And then the solid green line is the average of all the dynamical models. The maroon line, actually no, the solid green line is the average of all the statistical models. And then the maroon line is the average of all the dynamical models. Make sure I get that right. We do see that we do dip in early winter just below minus 0.5 degrees Celsius for these water temperature anomalies in Nino 3.4 region. So based on looking at this data here on all the modeling, taking the average of the dynamical and statistical models, we see a weak La Nina to start the winter, transition to ENSO neutral in January. And we're looking at water temperatures forecast to be about minus 0.6 degrees Celsius there in the Nino 3.4 region, warming to minus 0.4 degrees Celsius in Nino 3.4 region. And again, I'm favoring more along the lines of the 2001 winter season with that temperature forecast. We look at past winters and the quasi-biennial oscillations, the QBOs. 1971-72 winter had a positive or a westerly QBO. The 1983-84 winter season had a negative or easterly QBO, and these were the QBO values. It ranged from -10 to -12 throughout the winter months for the QBO value. The 2001 winter season also featured a negative or easterly QBO with a QBO range, the values ranging from -14 to -16 during that winter season. The 2016-17 as well as the 2022-23 winter seasons featured a positive or a westerly QBO. So if we just look at the past winters and QBOs, and we're expecting to see an easterly QBO this upcoming winter, we see that 1983-84 and 2001 could be possibilities here for winter analogs based on the fact they were easterly QBOs. We look at the easterly QBO plus a weak La Nina. So winters with weak La Ninas and a QBO that was negative in November and stayed negative all winter into March. Now this graphic is courtesy of weather risk, but we're showing generally well below normal temperatures. These are temperature anomalies here. The deeper the blue, the greater the colder temperatures below average here across the Midwest into Missouri, Illinois, Indiana, and Ohio. We do see below normal temperatures going all the way to the East Coast, even down to the Gulf Coast. The yellows and oranges indicate above normal temperatures across the western United States, including Nevada and California, as well as Arizona. If we look at easterly or negative QBO values and the winter months, whenever we have the QBO values in the months of December, January, and February ranging between -10 and -15, you see how below normal conditions are across the upper Midwest, down to the Ohio Valley and East Coast, across New England as well. You see a lot of below normal readings here in the purples. The lighter magenta color here indicates even greater colder temperature anomalies. Meanwhile, with a QBO that is negative between -10 and -15 in the winter months, you see above normal temperatures across Washington State, Oregon, California, and Nevada out in the western U.S. Over on the right-hand side, this is December, January, February, those months with negative QBO values between -15 and -20, and you still see very much below normal temperatures across the upper Midwest, down towards Illinois, Indiana, Ohio, parts of Pennsylvania, New York State, also down into Kentucky and Tennessee, and that blue stretches all the way into Virginia and the Carolinas. So well below normal temperatures for these winters whenever you see the QBO values between -15 and -20. So in any case, -10 to -20, things look rather cold across the Midwest and the East Coast. If we look at past winters, these winters that I've examined to be potential analogs, we look at those past analog potential winters and the Pacific Decadal Oscillation, the PDO. Now, if you look at the upper right here, this is the examples of a warm positive phase of the PDO. Here on the upper right, you see warmer than normal temperatures with a positive phase of the PDO, warmer than normal temperatures from the Gulf of Alaska down the west coast of Canada and the west coast of the United States, with a cooler than normal water temperatures there across the north central Pacific. That's a warm phase or positive phase of the PDO. We look at the negative phase or the cool phase of the PDO, it's the reverse. Typically with the cooler negative phase of the PDO, you have colder than normal temperatures stretching from the Gulf of Alaska, there in the northeastern Pacific, off the west coast of Canada and the west coast of the United States. And then you see warmer than normal temperatures out over the north central Pacific. So it's a flip in the water temperature anomaly pattern. And by the way, the warm positive phase of the PDO and the negative cool phase of the PDO, typically each phase lasts about 20 to 30 years. So it's not a quick reversal, like El Nino La Nina is typically a cycle of 3 to 7 years, whereas the PDO is a cycle which is much longer in duration, 20 to 30 years. So we're talking 2 to 3 decades. If we look at the past examples of the past potential analog winners in the PDO. 1971-72 featured a negative PDO. 1983-84 featured a positive PDO. 2001 featured a neutral to slightly negative PDO. And then we see 2016-17 featured a positive to a neutral PDO. And then 22-23 winter season featured a negative PDO. We have entered the range here in the bottom right here. You see these blue bars here that extend downward. This indicates blue colors on this graph here in the bottom right indicate a negative PDO. The red vertical bars extending upward indicate a positive phase of the PDO. So you can clearly see that we're deeply into a negative phase of the PDO right now, into this 2025 year. Now, if you were to look at this example here, hey, what can I use based on PDO as potential winner analogs? Well, technically, I could use 71, 72, right, because I have a negative PDO. I do have a negative PDO in 22, 23 winter season too, so yeah, maybe I could use that. And then my 2001 winter season analog, the negative PDO is there as well. It's slightly negative. It's not very strongly negative, but it's still negative nonetheless. Now, if we look at the past winters and the Pacific North American pattern, the PNA, now keep in mind with PNA, if you get a negative PNA during the winter season, that typically means you have upper level trough across the western United States, unsettled weather, a lot of storminess, well below normal temperatures with a negative PNA, trough across the western U.S., ridge across the eastern U.S. The ridge across the eastern U.S. with a negative PNA winter would feature more of drier and milder than normal conditions. So we look at 71, 72, and we see a negative PNA. Okay, 83, 84 winter season, we saw a negative PNA in the month of December. Then it transitioned to more of a positive PNA in January and February. The 2001 winter season had a positive PNA in December and January, and then it transitioned to slightly negative, the PNA, in February. The 2016-17 winter season featured a negative PNA in December, then slightly positive in January and February, and then the 22-23 winter season featured a negative PNA in December and February, and in between December and February, we switched to a positive PNA in January. So one big thing here to note, it's very rare to get an entire winter from start to finish with either a negative PNA or a positive PNA. These troughs and these ridges get basically moved from west to east in the westerly wind belt here in the mid latitudes. So it's very rare. The troughs and the ridges usually swap back and forth between the western U.S. and the eastern U.S. And I always mention this to folks. Usually what's going on in the western U.S., the opposite effect occurs in the winter in the eastern U.S. So let's say we have a negative PNA like the entire winter in 71, 72, we would typically have a trough much below normal temperatures that winter across the western U.S., and it's the opposite weather on the east coast of the U.S., much milder, drier than normal. That's typically the way the wavelengths work with, the long wave pattern where you get the troughs and the ridges. We look at the Madden-Julian oscillation MJO comparisons. Now I've got October through December 2000 over here on the left. And then I've got October of this year right now. This is my latest forecast from the Jeff's model. Now look at the similarities here. On the left-hand graphic, I just want you to pay attention to the red line. Just to the red line here on the left-hand graphic. The red line indicates the MJO for October of the year 2000. And notice how we have the MJO rotating into phase 3, 4, 5, and even into 6 during the month of October in 2000. Now, over here on the right-hand side, let's look at the forecast, the current forecast for the MJO according to the Jeff's V12 model. We're rotating into what? We're rotating into phase 3. We're rotating into 4. We're rotating the MJO into phase 5 by Halloween, the 31st. Do you see the similarities here? This red line and how it wraps around from phases 3 through 6. And look at over here, the forecast. The MJO is wrapping around from phases 3, 4, 5, and potentially into 6 in early November. But you see the general progression of the MJO is very similar between October 2000, the red line on the left, and the current forecast over here on the right. We look at past winters in the Arctic Oscillation. Let's examine this. So again, just like the PNA, it's very rare to just get one consistent Arctic oscillation the entire winter. It usually adjusts from positive to negative and flips back and forth over the course of 3 months, those meteorological winter months. And we look at 71, 72, we saw a positive AO in December. Oh, and one more thing before I get into the breakdown of the winters, of the potential analog winters. The positive AO basically results in milder temperatures across the eastern United States. Much of the coldest air remains up over the Arctic with a positive AO. With a negative AO, it's a different story. You get much colder temperatures in the eastern United States with a negative AO. I just want you to think about that as I go through what happened in these previous winters. So 71, 72, positive AO in December. We should be able to look at a temperature anomaly chart and it should be relatively above normal in the eastern United States in December of 71. And as well as January, it was positive. Slightly negative AO in February, which means we should be a little bit colder in the eastern U.S. 83, 84 winter season, we saw a positive AO in December and January, which would indicate warmer temperatures. They should indicate warmer temperatures if we just looked at AO alone. Slightly negative AO into February of 84. 2001 winter season, we had a negative AO primarily throughout the entire winter that year. Just impressive to be able to run the table from start to finish in winter with a negative AO. And then we have the 2016-2017 winter season. We had a positive AO that entire winter. And then 22-23 winter season, we had a negative AO in December and January. And when you see negative AO alone, you'd expect colder than normal temps in the eastern U.S. And then we transition to a positive AO in February of 2023. And so you can see over here on the right-hand side, I'm breaking things down just with words, but over here on the right-hand side backs up what I'm saying. This is a running archive of the Arctic oscillation in the past years. We look at the past winters in the North Atlantic oscillation, the NAO. Why do we care about the NAO? Because when the NAO is positive, we typically see milder temperatures in the eastern U.S. When the NAO is negative, we see colder temperatures in the eastern U.S. So 1971-72 winter season, we saw a positive NAO the entire winter primarily. The same thing goes for 83-84, primarily a positive NAO. The 2001 winter season, we saw a negative NAO in December, and that backs up the temperature anomalies. I'll show you those here, what the temperature anomalies were in December of 2000. Negative NAO, and it was very, very cold across the eastern U.S. And then we had negative AO as well at the same time. So I'll show you what those temperature anomalies look like in December 2000 here momentarily. But then in January and February, the 2001 winter season, we saw a positive NAO. 2016-17 winter season, positive NAO, primarily through the entire winter. And then 22-23, a positive NAO. We look at the past winters and these past potential analog winters in the stratospheric polar vortex. 1971-72, there were no sudden stratospheric warmings. Now, typically, sudden stratospheric warmings means that have very warm temperatures in the stratosphere over the Arctic area. And when I get very warm temperatures in the stratosphere over the Arctic area, that typically weakens my stratospheric polar vortex. The weakening of the stratospheric polar vortex can take on many forms, from displacements to splits. You get a polar vortex stretching event as well. So when I say sudden stratospheric warmings, when I say there are none for a particular winter, that generally indicates the polar vortex was not as weak. It was actually a little bit stronger. So 71-72, no sudden stratospheric warmings that winter. 83-84 winter, we saw a sudden stratospheric warming take place, but it didn't take place till later in the winter, on the 24th of February of 1984. And by the way, the 83-84 winter season featured a La Nina and a positive or westerly phase of the QBO. We look at the 2001 winter season, we saw a sudden stratospheric warming a little bit earlier on the 11th of February 2001. And this winter, the 2001 winter, featured a La Nina and that negative or easterly phase of the QBO. 2016-17, there were no sudden stratospheric warmings. So you generally tend to associate that with a stronger than normal polar vortex in the stratosphere and milder temperatures across the US. 22-23 winter season, we saw a sudden stratospheric warming that occurred on 16th of February 2023. We had a La Nina and a positive or westerly QBO in the 22-23 winter. So you look at when the sudden stratospheric warmings occurred in these La Nina winters, and in a lot of cases you see 3 of these 5 winters where we had a sudden stratospheric warming, they occurred in the month of February, later in the winter. We look at this graphic now provided by, this is from NOAAclimate.gov. Dr. Amy Butler, this was adapted from the original by Dr. Amy Butler. Okay, so what are we looking at over here on the left? Okay, we're looking at La Nina. First of all, let me just break this chart down. So anywhere above this, see my red little dot here, anywhere above this 0 line, that indicates more of a positive or westerly phase of the QBO up here at this location. Okay. When we look down here, you see generally what we got going on here is these are the water temperature anomalies along this horizontal axis at the bottom of the graphic. These are the QBO winds over here on the vertical axis. So again, positive values on the vertical axis, 0 to 20 meters per second, indicates a westerly phase or positive QBO. Anything in the negative values on this vertical axis indicate easterly or a negative phase of the QBO. And the horizontal bar here, anything in the negative values over here for water temperature anomalies indicates La Nina conditions. Anything over here to the right on this horizontal line, the right of 0 and the positive values indicates El Nino conditions. Okay, so if we combine the effects of the QBO phase plus the ENSO state, we get these different dots in the different quadrants of this graphic, okay? You notice we're looking at December through February polar vortex relative strength in meters per second. So whenever you see green dots in any of these quadrants, that indicates a weaker polar vortex. Whenever you see the purple coloring, the very dark purple coloring, that indicates a much stronger polar vortex. All right, so the weakest polar vortex years on this graphic are generally in the dark green dots, and they generally are associated with the easterly QBO winters. Okay, winters with at least one polar vortex disruption, sudden stratospheric warming, are marked with a black outline, and years with 2 have 2 circles. All right, so in general, what we're expecting this winter is an easterly phase of the QBO plus La Nina. So we would be in this lower left-hand quadrant right here. Easterly QBO plus La Nina. Now look at the coloring again. If they're negative values in the green colors, the green dots here indicate a weaker polar vortex. So you notice with a easterly QBO that we get a lot of these green dots. And that's generally associated with these sudden stratospheric warmings or weakening polar vortex situations. You notice over here between 0 and -1, the value 0 to -1 in La Nina territory, you have more of a cluster of these dots here, right? And that indicates more sudden stratospheric warming events when the water temperature anomalies range up to -1 degree Celsius below normal in the Nino 3.4 region. So you notice the westerly QBO, you're getting a lot more purple colors up here in the westerly QBO, these top 2 quadrants, and that's associated with the stronger polar vortex. So bottom line is, during easterly QBO winters, we typically have a 92% chance for some sort of weaker stratospheric polar vortex. So just wanted to throw that out there. If we look at the sea surface temperature anomalies now, and let's compare these. I did this yesterday, and let me see if I can draw, kind of like highlight, or let's see what I can do here. Let me try this here. Okay. All right. So what we're going to look at is the comparisons on the upper left sea surface temperature anomaly chart from CDAS. This is today, the upper left. Bottom right is from December of 2000. Okay. All right. So let's see if there's any kind of, these are sea surface temperature anomalies. When you see the orange colors, that indicates above normal water temperatures, and I'm mainly focused on the Pacific. When I see blue colors on these graphics, it indicates below normal temperatures, cooler than normal temperatures in the water. So let's examine things. Let's look at the Western Pacific first. Between the two areas, let me go ahead and change the color of this. Okay, so above normal water, currently here in the upper left on the sea surface temperature anomaly chart in the Western Pacific around Japan. And in December of 2000, I had above normal water as well in the same location. See that? So I'm going to circle one graphic chart here, the current chart here in the upper left, and then the December 2000 in the bottom right, and kind of circle the areas that are similar. All right, notice that we had above normal water temperatures across the Pacific here, North Pacific. We have that going on right now in the upper left, and we have similar above normal water temperatures in the North Central Pacific, again, just to the northwest of the Hawaiian Islands now. So do you see the comparisons here, right here, and then here? Okay, so those match up pretty well. Now, we do have much colder than normal temperatures, but this is the month of December in the bottom right, so things are going to be cooler. But you generally see this patch here. Let me get out of that there. You generally see this blue color here across the far northwestern Pacific, and it's very similar here on the bottom right from December 2000. So we're getting features that match up fairly well. You notice the La Nina down here in the tropical areas. This was December of 2000 on the bottom right, and then this is currently what's going on right now. So you see that the comparisons are there. I can identify 4 distinct areas where we have similarities in these sea surface temperature anomalies. And one other thing here in the bottom right, this is from December 2000, showing a Central Pacific-based La Nina, where the coolest anomaly water temperature anomalies were out in the Central Pacific. So just wanted to compare. I thought there were quite a bit of similarities between today on the upper left, this graphic on the upper left with the water temperature anomalies, and the bottom right here from December of 2000. We look at the sea surface temperature. We're going to break this down now for the winter of 2001. So I'm going to start off here in the upper left. Orange colors, or the left-hand graphic here, orange colors indicate above normal water temperatures, blue colors below normal water temperatures. So for December of 2000 on the left, we see we have the Central Pacific-based weak La Nina, where the coldest temperature anomalies across the central tropical Pacific. We do see some warmer than normal temperatures northwest, water temperatures northwest of Hawaii, below normal water temperatures across the northwestern Pacific. We look at the temperature anomalies. These are the air temperature anomalies on the right for December of 2000, and look at how cold things were across Iowa, southern Minnesota, Illinois. We're running 14 to 15 to 16 degrees below normal across those areas. But it was generally cold east of the Rocky Mountains, down the Gulf Coast, up the eastern seaboard to New England. It was a very cold month in December 2000. This was the sea surface temperature anomaly configuration across the Pacific. And again, when we compare what's going on right now here in the upper left to December of 2000 down here in the bottom right, there are some interesting similarities. We look at the January 2001 sea surface temperature anomaly chart in degrees Celsius, orange above normal, blue below normal. We see above normal water temperatures there northwest of Hawaii across the central Pacific Ocean. We also see above normal water temperatures across the western Pacific, specifically in the tropical areas east of the Philippines. We do see below normal in the blues there across the northern Pacific Ocean. And then these were the air temperature anomalies on the right for January of 2001 across the United States. We saw below normal temperatures in the greens, 5 to 6 degrees below normal in Florida, along the Gulf Coast, up to Mississippi, Louisiana, Alabama. We still saw some slightly below normal average temperatures there across parts of the mid-Atlantic, ranging from 1 to 3 degrees below normal. We saw well above normal temperatures up across the northern plain states in January of 2001. Now let's look at February of 2001 sea surface temperature anomalies, showing above normal water temperatures from the tropical western Pacific through the central North Pacific, just northwest of Hawaii, well above normal water temperatures. And then we saw below normal water temperatures along the U.S. West Coast, across the northern Pacific Ocean, and also back towards the northwestern Pacific Ocean. What were the air temperature anomalies for the United States in February 2001? We saw below normal air temperatures rather in eastern Montana, the Dakotas, and Minnesota. Temperatures were running 9 to 11 degrees below normal. We saw above normal temperatures now across the eastern U.S. So things flipped from slightly below normal to slightly above normal. We're talking 2 to 4 degrees above normal across Virginia and the Carolinas. Now, if we look at the forecast, the NMME forecast for the sea surface temperature anomalies for the months of December, January, and February, coming up, the 25-26 winter months basically, we see blue across the central tropical Pacific in association with a weak central Pacific-based La Nina. You notice where these water temperatures are in the central tropical Pacific, not along the immediate west coast of South America. So we expect more of a weak central Pacific-based La Nina for the winter, specifically the early part of winter before we transition to ENSO neutral. Look at the above normal water temperatures that are predicted up in the central Pacific, northwest of Hawaii, back towards the northwest Pacific, and then near average water temperatures along the U.S. west coast into the Gulf of Alaska. Now, this is the latest forecast from NMME. So my potential winter analogs, if I break down all the factors we discussed, okay, when we talk about, let me go back here. We talk about the weak La Nina winters transitioning to ENSO neutral. Okay, so weak La Nina to ENSO neutral winter transitions. These are the potential fits that meet that criteria. We look at the past winters in the QBOs, we have a couple potential winter analogs. Again, based on the negative phase, the easterly QBO, which we're expecting this winter. If we look at past winters in the PDO, we're looking for negative PDO because that's what we expect this upcoming winter season. There's a couple that could meet the criteria, right? If I went just solely off negative PDO and based on the forecast this upcoming winter for negative PDO, I could potentially use 3 winter season analogs, 71, 72, 2001, and then 22, 23. And we look at the past winters in PNA, this is kind of like what happened in those winter seasons. And then the MJO comparisons to present time, the AO in the past winters, and then the past winters in NAO. And then the past winters of what happened with the stratospheric polar vortex. And we talked about the weakest polar vortex years tend to occur in easterly QBO winters on this chart. So we look at sea surface temperature anomalies, we compare those, what was the 2001 winter season like, and then we look at the forecast again of where we expect the warmest and coolest water temperature anomalies for this upcoming winter season. We put it all together, and I can narrow things down honestly to 83-84 winter season. We went La Nina to ENSO neutral that winter. And we saw easterly QBO. Okay, well, we're supposed to have an easterly QBO this upcoming winter, so that's a match. The transition to ENSO neutral, that's a match. A positive PDO, though. So there was a positive Pacific Decadal oscillation. That would mean warmer than normal temperatures along the U.S. west coast, up off the west coast of Canada, and much cooler ocean temperatures across the north central Pacific. Well, we really don't have that going on right now, right? Let's go back. We have warmer than normal temperatures across the north central Pacific right now. And we're not really expecting that to change much based on this NMME forecast. See the orange colors here across the north central Pacific? If we had a positive PDO, this would be blue. This would be below normal water temperatures across the north central Pacific, not warmer than normal temperatures in the water. So, that positive PDO kind of throws that 83-84 analog off a bit. And then we also have the 83-84 winter. Remember, we had the westerly QBO, not the easterly QBO. So go back to my QBOs here. Where are we at here? Right there. 83-84. Okay, hang on a minute. Hang on a minute here. No, we did have an easterly QBO. I don't know why I put westerly QBO here when I put easterly QBO there. So it was easterly QBO. So the QBO would fit for 83-84 actually. Forgive me for this error here. Just crunching a lot of data lately. So we did have an 83-84 easterly QBO, but that positive PDO is the difference for the Pacific water temperatures, okay? Now, to me, the most favorable winter analog remains 2001 winter season. I really like this winter season analog. We had the weak La Nina to start that winter. We had sea surface temperature anomalies. They started out at minus 0.7 degrees Celsius in the Nino 3.4 region and warmed by January to minus zero point 0.5 C. So that's kind of right on that borderline between ENSO neutral and La Nina. Based on the forecast I'm seeing by IRI, it looks very similar for this upcoming winter season. We did see an easterly QBO in the 2001 winter season. We saw that slightly negative PDO, which we have a negative PDO this winter. And then I talked about the similarities, a lot of the similarities to the North Pacific sea surface temperature anomalies. So I still am very bullish on the 2001 winter season as a primary analog. And, taking a look at all these factors, all the teleconnections over these past winters, um, you know, um, what things look like, QBOs, the weak La Nina and ENSO neutral conditions. I'm really liking what I'm seeing with the potential of 2001 winter season. Where again, right hand side, this was December of 2000. It was a very cold December from the Midwest to the East Coast, and it was still fairly cold, specifically across the Deep South in January. And even colder than normal, a little bit colder than normal across the mid Atlantic states for January. And yeah, I mean, look, February did flip around, so we'll see what happens this upcoming winter. But in general, you see what happened here. We had a Central Pacific based La Nina, which that's what it's looking like this winter. So there's just a lot of good matches here that match up with 2001 winter season. So I'm still sticking with that as my primary winter analog. All right, that wraps up this video, part two, winter seasonal forecast considerations. Hopefully you learned a lot here from the video. I try to break things down into more simplistic terms. And yeah, that's all I got for now, everybody. And until next time, God bless and take care, everyone.